Okay, Algebra 2, this is part 2 of section 9.2, where we talked about angles and angle measures in my last video. Now we're going to talk about something called radians, which you probably don't know a whole lot about because we don't ever talk about this in any other math class before now. So, just as kind of review, we talked about angle measures, and I had you guys draw out those 4 different quadrants, and we talked about how many degrees each kind of quadrant was. Okay, so if I have an angle, all my angles are going to start here in this first standard position. Okay, and if I rotate this angle up here to this point, that's going to be just 90 degrees. Okay, of kind of a rotation angle. Okay, so this angle right here is just 90 degrees. If I start here and I rotate all the way over to this part, meaning I kind of flip that angle around, that's going to be 180 degrees. Okay, starting here, rotating around until this point is going to be a measurement of 270 degrees. And then going from this standard starting point all the way around back on top of himself is going to be a 360 degree rotation. So basically, this line is like living on top of himself, so it's not even really making an angle. It's kind of like 0 degrees, but 0 degrees and 360 degrees are going to be the same as each other, and another word for that is coterminal angles. So those angles would be coterminal because they have exactly the same starting and ending point. Okay. All right. So now let's talk about what a radian is. Okay. So we have degrees and then we have radians, and most of the trig stuff that we do will involve being in radians. Okay. So here's how this works. Think about a coordinate plane, and if I would put a circle on top of that coordinate plane. Okay. And we're going to do a circle with a radius of 1. So that means the distance from here to here, from the center to the outside, is a length of 1. Okay, so this is how this is going to work. If I'm talking about the circumference, which is all the way around the circle, okay, the circumference, the equation for finding circumference is 2 times pi times r, okay? Or 2 times pi times the radius. That will give you the distance all the way around the circle. Okay. Well, if I'm dealing with a circle that has a radius of 1, okay, and I plug 1 into this spot, that will just give me 2 pi, right? Okay, and 2 pi is a decimal 6.28 approximately. So basically, if this is 1 foot, and I were to walk around the outside of this circle right here, I would have gone 6.28 feet approximately. Okay. Now here's the deal. Here's how this works. 6.28 feet, or 2 pi, is the same thing as me starting here and going all the way around back to where he started from, which is kind of like going 360 degrees, okay? So 360 degrees is equivalent to 2 pi all the way around the circle, but this is in degrees and 2 pi is in radians, okay? So basically that's the conversion between the two. 360 degrees is equivalent to 2 pi. Okay, so then let's think about 180 degrees would be me starting here and stopping over here. This would be 180 degrees. Okay, so kind of think and see if all the way around the circle would be 2 pi, what would just be halfway around the circle, or 180 degrees? That would be just like going pi units around. Okay. Because that would be the circumference, or the distance that I would have traveled. Like 3.14 feet is how far I would have traveled. Okay. Now, if I'm going 90 degrees, so I'm just going a quarter of that. Okay. 90 degrees, not percent, degrees. 90 degrees from here to here. Okay. If this is a distance of pi from here to here, then this would be half of a pi. Okay. And they will label that as pi over 2. Okay, so a distance of pi divided by 2. And then 3/4 of the way, so from here on down to here, okay, here's pi, here's 2 pi, halfway in between that would be 1.5 pi, or 1.5 pi, which they will write as 3 pi over 2. So it's like three halves of a pi. Okay, so I'm going to write that out again down here because this is really important. So I have 0 degrees. We'll fill this in without any of the mushy stuff. Okay, 0 degrees or 360 degrees. That's the equivalent of 2 pi. Let me put that in a different color, 2 pi. Okay, that's how many radians that would be. Okay, if I'm going from here around to here, that would be 180 degrees, or just 1 pi. Okay, if I'm going just 90 degrees, that's half of a pi, or pi over 2. And if I'm going 3/4 of a pi, or 270 degrees, that's the same thing as going 3 pi over 2. Okay. Now again, that 2 pi comes from the 2 pi r, which is the circumference of a circle. So 2 pi would be all the way around. Same thing with 360 would be all the way around. Okay. So now they're going to talk about how this relates from degrees to radians. So 2 pi is the equivalent of 360 degrees. Okay. Which means that 1 pi is the equivalent of 180. That's what we just wrote down here, okay, on our unit circle. 1 pi is 180 degrees. So what they're going to have us do is down here, they're going to say, rewrite the degree measure in radians and the radian measure in degrees. So this guy is in degrees. -30 is a degree measurement, okay? So think about where -30 would be, okay? +30 would be up here in the first quadrant, okay? Something like this. -30 will be down here, just 30 degrees below the x-axis. Okay, so that would be -30 degrees approximately. They want us to rewrite this degree in radian measure. Okay, so what we're going to do first is we always take the degree and we put it over 1. Okay, and then what I'm going to do is I'm going to either multiply by pi over 180, like it says here, or I'm going to multiply by 180 over pi, because 180 degrees is equivalent to pi. Okay, so I either use pi over 180 to convert, or 180 over pi to convert. Okay, all right, I'll let you get that written down for just a second. And the way that I decide which one to use is this, the way that it's written here. So I have degrees up at the top here, and when you're doing unit conversions, you always want to have them cross each other out. So I want my degrees to be on the bottom here. That means I want 180 degrees to be down here at the bottom, okay? And then I want to put pi up here at the top, okay? And that is so that those degree measurements can cancel out with each other, right? We learned in algebra that you can only cancel if one is on the top and one is on the bottom, okay? So crossing those degrees out, that's how I want to do that. And then I want to just reduce anything that I can. So -30 and 8 I can cross, or and 18 I can cross off as 0. But then also 3 and 18 will reduce. The 3 can become 1. The 18 can become 6. And really, since it's -3, we should put a -1 over there. Okay, so what I will have on the top here is -1 times pi, or negative pi. And then on the bottom, I'll just have 6, and that's what he will look like. So -pi over 6 is what he will be. Okay, so not quite pi over 2, -pi over 6 would be down here below because it's negative, but that's where he would look like. Okay, so -30 degrees is the equivalent of -pi over 6, and that is in radians. Okay, all right, the next one, they say 5 pi over 2. Okay, 5 pi over 2, if I take 5 and divide by 2, that's 2½ pi's, right? 2½ pi's. So if 2 pi is one full circle all the way around, 2½ pi's is going to be one full circle and a half of a circle, right? It's going to land me kind of over here, okay? So let's figure out how to convert 5 pi over 2 to degrees, okay? So, because this is in radians, so maybe you want to label that. He is in radians, and we want to go to degrees. Here he was in degrees, and we wanted to go to radians, okay? So, now here's where I decide, do I want to use pi over 180 or 180 over pi? And the way that I decide is the pi up here is on the top. That means I want pi to be on the bottom so that it cancels on the bottom. Kind of like I had degrees up here on the top. I want degrees down here on the bottom so that they will cancel, okay? So I have 180 degrees over pi so that this guy will cancel with this guy, Okay, and then all I do is multiply the tops and the bottoms together, except I guess 2 and 180 will reduce. Okay, so 2 will become 1, 180 will become 90, because 180 divided by 2 is 90, and then all I have to do is take 5 times 90 divided by 1, which is really 450 degrees. Okay, 5 times 90 will be 450 degrees. Okay, and that's what 5 pi over 2 will be in degree measurement instead of radians. Okay, so that's kind of how you go between the two. Okay, all right, the last thing that they're going to talk about is the length of arcs. Okay, so instead of going the full way around the circle, they're talking about, okay, let's say I would just walk this little pie crust right here. Okay, I want to just walk that far. I'm not going to go all the way around the circle. I'm just going to walk that pie crust. Okay, well, some terminology that they use is a central angle. So they have a central angle labeled here, which, you know, in this case, this is an acute angle, so maybe that is 60 degrees. Okay, it kind of looks maybe like he's 60 degrees. 90 degrees would be a perfect right angle, so 60 degrees, a little bit less than that. You know, that's what a central angle is. A central angle of a circle is an angle with a vertex at the center. So here's the center of my circle, and then it's intercepting that arc right there. Okay, so that's 60 degrees. Okay, now if we're trying to find the length of that arc, okay, so looking at this diagram, and they tell me, okay, your piece or your pie is let's say 5 inches in diameter, or in radius. Okay, so the diameter all the way across would be like a 10-inch pie, right? And I'm going to eat, let's say I'm going to eat 60 degrees of it. Okay, what would be the length of that pie crust here? Okay, I could figure out what that would be. Okay, and the way that I do that is by looking at S. Okay, that's what they label for the arc. So S is going to be the arc length, or the, if you want to put crust length, that's what S is representing. And then R is the radius. And this little symbol right here, we've talked about before, is called theta, and that is the angle. But the angle needs to be in radians, okay? Not in degrees, in radians. Okay, so we might have to do some conversions first. But basically, I can figure out the length of that pie crust by taking the angle, which would be 60 degrees, times the radius, which is 5. Now, we have to convert that 60 degrees to radians first, because this is in degrees, not in radians. But if after we convert that, we could just take this times that, and that would give us the length of this arc right here. So kind of handy. That's why radians are so nice. All right, so monster truck tires have a radius of 33 inches. Okay, so I'm going to draw this circle right here. Here's my monster truck tire. That's a pretty decent monster truck tire. There's the center, okay, and the radius is 33 inches. So I'm going to label him 33 inches. Okay, how far does the monster truck travel in feet after just 3/4 of a tire rotation? So 3/4 would be like going from here all the way around to here. Okay, that's 3/4 of a rotation from here all the way around to there. Okay, so think about how many degrees that would be. How many degrees do you think would be 3/4 of a rotation? We've talked about this before. How many degrees is 3/4 of a rotation? That is going to be 270 degrees. Okay, 3/4 of a rotation. All right, so what we need to do is to figure out how the length of this guy, that's S, we would just need to take the radius times the angle theta. Okay, all right, so our radius here is 33, and then we need to figure out what our angle is. Okay, and that's what we don't know. All right. We know that the angle is 270 degrees, but it has to be in radians, not in degrees, in radians before we can plug this in, okay? So 270 degrees, okay? If I put that over 1, what I can do is convert them, all right? And I want to either do pi over 180 or 180 over pi. But if I have degrees on top here, I want to make sure I have degrees on the bottom here. So the 180 is going to go on the bottom, okay? And the pi is going to go on the top. All right, and then I can just reduce. So I know that the zeros can cross off. 18 and 27, both of them are divisible by 9. So 18 divided by 9 is 2. 27 divided by 9 is 3. So this guy will be 3 pi over 2, right? I think we talked about that on the front side here, or on this side. 270 degrees. Let's see. Right here, 270 was 3 pi over 2. There we go. We've converted it. We've seen why it is, and there he is. Okay, 3 pi over 2. Now, I want to take this, and I want to put him in this spot, 3 pi over 2. And then all I'm going to do is multiply that by 33, and that's going to give me the distance that the monster truck tire has traveled. Okay, so 33 on, you're going to need your pi button, 33 times, I'm going to use parentheses, exactly how I'm going to type this in, 33 times 3 pi, my pi button is right here, 3 pi over 2. Okay, just like that. That's how I'm going to type him in. Enter. And it is 155.5. Okay, 155.5. Now what? 155.5 what? Since our radius was in inches, the monster truck has traveled 155.5 inches. Not very far, but again, we're only going 3/4 of a tire rotation. Okay, so that's not very far. But there's that. Okay, so the length of the arc is the radius times the angle, but the angle needs to be in radians first, so you're going to have to convert, and then you can just multiply them together. Okay, that's all I have.